Here we start by defining what we mean by half-life, and then do an example related to half-life. So half-life is a measure of the stability of a radioactive substance. That's simply the time it takes for one half of the atoms in an initial amount to disintegrate. So this measure time it takes for one half of the atoms in an initial amount, say A naught, to disintegrate or transmute into the atoms of another element. So example, a breeder reactor converts uranium-238 into the isotope plutonium-239. After 15 years, it is determined that only 0.043% of the initial amount A naught of plutonium has disintegrated find the half-life of this isotope if the rate of disintegration is proportional to the amount remaining. That's a good problem to illustrate how to find half-life from ordinary differential point of view. Now, solution of this so let A of t be the amount of plutonium remaining at any time t. Then we solve the initial value problem dA dt equals to Ka, where A at 0 is A naught. Now, so by separation of variables, we have dA over A equals to K dt. On integration, this gives ln of A kt plus c. Exponentiating both sides, A will be given by e raised to power kt plus c. Using loss of indices, so where C1 is this constant, e raised to power c. So this means that A of t is given by C1 e raised to power kt. But A at 0 is A naught. So which means A at 0, which is A naught, is C1 k times 0, which implies A naught is C1. So therefore, the solution of the initial value problem is A of t equals to A naught e raised to power k t. Now this information that after 15 years, 0.043% of the initial amount has disintegrated. So which tells us that what's remaining is 100% minus 0.043%. This will be 100 minus 0.043, 99.957% remains. So therefore, we say if 0.043% of the atoms of A naught have disintegrated, then 100% minus 0.043%, which is 99.957% of the substance remain. So then, to find the decay constant, we use that this So this is the same as 99.957 remaining. So the same as 0.99957 of the initial amount A0 is the value that we have after 15 years. So which means 0.99957 A0 is the same as A0 e raised power 15k, because now time here is 15. So I'm replacing this those values in this solution. So this implies e raised power 15k is 0.99957. So which means ln on both sides will give us 15k equals to ln of 0.99957, which gives k to be ln of 0.99957 over 15. K will be negative 0.12345867283 So now the equation will be, or the solution will be A of t equals to A naught e raised power negative 0.0002867283177 t. Now, the half-life is the corresponding value of time at which A of t should be a half of the original value. So, which means if I replace a half A naught into this solution, I should get A naught e raised power negative 0.123428672833177 t. Dividing through by A naught, we get e raised power negative 0.123428672833177 t equals to a half. Now, getting ln on both sides will have 0.123428672833177 t equals to ln of 0.5. So t will be ln of a half over negative 0.123428672833177. So this will give us 24,174.3 5383. So which is roughly 24,174 years. So that's how we get the value for half-life of that given material. And then number 2, a fossilized bone is found to contain 1,000 of carbon-14. So estimate the age of the fossil given that the half-life of carbon-14 is 5,600 years. Now, to solve this, the governing equation for this case is still dA dt equals to Ka. A at 0 is A naught. So where A is the amount of carbon-14 anytime T. So solving, as we have done in the previous case, we get A of T is A naught e raised power K T. Now to determine the value of the decay constant K, we use the fact that a half of the amount is after 5,600 years, or a half A naught equals to A naught e raised power 56. So when you put 5,640 in this equation, this solution, this implies that a half equals to e raised power 5,600k, which means getting ln on both sides is 5,600k is ln of a half. So k is ln of a half over 5,600. So ln of a half divide 5,600 is negative 0.1234. So therefore, we get A of t is A naught e raised power negative 0.123 t. Now I've been told that a fossilized bone is found to contain 1,000 of carbon-14. So which means then A of t is found to be 1/1000 of the original amount A naught. So using this, we need to find the value of t. So I'll have 1/1000 A naught equals to A naught e raised to the power negative 0.000012377762822t. So dividing through by a naught, we get e raised to the power negative 0.0001237762822t equals 1/1000. Now, introducing ln on both sides, we'll have negative 0.123/12377762822t equals to ln of 0.001. So which means t will be ln of 0.001 over negative 0.000012377762822. So ln 0.001 divide answer, we get 55,808.39199. So roughly 55,808 years. So that's what we get for that given question. Thank you.